All right, today you're doing solving quadratics. And what we have over here is our friend, the quadratic equation. If you remember what a quadratic equation is, it's, whoops, got the wrong pen on. Let me change that. It is ax squared plus bx plus c equals 0. And we see this almost fits a standard quadratic form. So today we're going to learn how to solve these. It's a classic algebra high school problem. First things, we know that every time we see an equal sign, we're solving for an answer. So we see right here that there is an equal sign. So we're obviously got to solve for x. We're going to have x equals 12, x equals 15, x equals something is our answer. Next thing. We must know that every time we see an x squared, we're going to have to factor to solve. So we see an x squared here. It's our highest. So we know we're going to use one of our GCF, difference of two perfect squares, or trinomial factoring. Even if we had an x cubed or an x to the fourth, we're going to have to factor to solve that. So anytime you see something with a higher degree than 1, you're going to have to factor. All right, so it's really not that hard. You guys have been through this, and I'm going to show you even an easier way to do this when we get to the end of the lesson. So here are your directions. Set equal to 0. As you can see right now, as I pointed out, this is set equal to 30. So I'm just going to take 30 and move it to the other side. I'll subtract 30, and my new problem is 2x squared plus 4x minus 30. Now I'm going to follow the factoring laws. Is there a greatest common factor? I have to look through these. Looks like 2 is the greatest common factor. So I'm going to make my life easy, and I'm going to pull out a 2 first. I still have that x squared hovering around, so I've done my first law. I'm going to see if it's a difference of two perfect squares. It can't be. There are 1, 2, 3 terms, so it is not a difference of two perfect squares. It must be trinomial factoring. Yes, indeed, it's a trinomial. 1, 2, 3. So for trinomial factoring, I want to find two things that multiply to negative 15 but add up to positive 2. And there you have it, 5 and 3. Notice 5 times negative 3 gets me my negative 15, and 5 plus negative 3 gets me my positive 2. So there you have it. Your answers are pretty much staring you in the face. Now mathematically, oops, let's get that out of there. Mathematically, what we do is we take each parentheses and we set it equal to 0. Each of these parentheses is called the factor. This is a factor, this is a factor. Because these three things, this, and this, these three numbers, when multiplied together, get me 0. So that means we take each factor and set it equal to 0. X plus 5 equals 0, x minus 3 equals 0. And some of you may be asking, do we set 2 equal to 0? Well, look what happens if you set 2 equals to 0. You get a false statement. 2 cannot equal 0. 2 is a constant. It's already one of our answers. So x plus 5 equals 0 and x minus 3 equals 0. When I figure it out, I see that my answers are x equals negative 5 or x equals 3. All right, so I'm going to show you that little shortcut right now, what I was talking about. You guys can take out your graphing calculators, and I have to go and use an online graphing calculator. There's a great online graphing calculator. You can see it up here, Desmos.com. First thing I'm going to do is I'm going to just graph my equation. I'm going to type in y, oops, equals 2x, and now to do a squared, we do a caret, which is above the number 6. That's how we do it on a computer, plus 4x, whoops, hit the wrong key there. You can see it's starting to take shape on the other side, plus 4x, and then I'm going to put in the minus 30, because remember I set it equal to 0. And look at, there it is. There's my quadratic. It's a parabola. Now I'm going to do one more thing over here. I'm going to pick a color. Let's see. And I'm going to pick, hopefully red shows up. And my next equation is going to be y equals 0. And if you saw on the screen over there, the line y equals 0 now has a red line going through it. If I choose points of intersection, there they are. Look at my answers. The same two answers you got right in the beginning by factoring. -5 and +3. These are the roots. This is where the parabola crosses y equals 0. And you can do that for anything that you need to factor. Okay? Here's our next problem. It doesn't quite look like a quadratic, but if I did a little math, I can see that I get x squared minus 2x plus 2 equals 1. So indeed it is a quadratic. I'm going to clean that up a little bit. It's going to be x squared minus 2x plus 1 equals 0, because I could combine these like terms. Now I'm going to follow all my factoring laws. Is there a greatest common factor? Nope, there's nothing in common. Greatest common factor I did. Is it a difference of two perfect squares? No, because there are 1, 2, 3 terms. It means it's a trinomial. So let's do trinomial factoring over here. Find two numbers that multiply to +1 but add up to -2. And when I factor there, I see that I have -1 times -1 does indeed get me my +1. And -1 plus -1 does indeed get me my -2. So we don't have to worry about doing factor by grouping because we've factored this completely now. We take each parentheses and set them equal to 0 because these are my two factors. I want to see when does that equal 0 and when does that equal 0. And when I set them equal to 0, look what happens. I get the same answer. Well, let's go back to our lovely calculator. Let's take this right here. We're going to delete it. Notice I'm going to keep the line y equals 0 because that's what we did. We want to set it equal to 0. We want to see when our quadratic passes through this y equals 0. So down here, I'm going to enter in our equation from before. And let me see, what is our equation? X squared minus 2x plus 1. So y equals x squared minus 2x, you can see it taking shape, plus 1. And there it is. And if I look at my points of intersection, it intersects what I want to see, which is where y equals 0, only once, at the point 1, 0. And that's what we got for an answer right there. X equals 1. So there's really only one answer to this problem, and it is the answer 1. That is where this parabola is set equal to 0. All right, last problem. You know what? I'm going to take a little shortcut right here. I'm going to set this equal to 0. So the first thing I have to do is multiply my x through. So that's 8x minus x squared. And it's set equal to negative 20 right now. So I'm going to move that 20 over so that it's set equal to 0. And this is what I get. And I'm going to go to my calculator right now. I'm not going to bother with doing the factoring. Let me go right to my calculator. And I'm going to type in y equals negative, y equals x squared minus, let's delete that, minus 8x minus 20. And let me see if I can figure out my points of intersection. So where does it intersect y equals 0? Right there at negative 2, 0, and way over here at n 0. It's right off the page. If I zoom in on the graph, how about if I zoom out on the graph? You can see it right there. So those must be my two answers, negative 2 and 10. Well, if I just factored for the heck of it, hey, look, when I factor, negative 10 times positive 2 gets me my negative 20. And negative 10 plus 2 gets me my negative 8. But I said my answers were 10 and negative 2. And oh, I see why. Because when I set each factor equal to 0, 10 minus 10 is how I get 0, and negative 2 plus 2 is how I get 0. So those are my two answers for this one. So isn't this wonderful? You guys can do this in your graphing calculator. You can do it in the y equals button. And I'll show you exactly how to do it tomorrow in class. But until then, you can always use this wonderful Desmos graphing calculator. Okay, guys, that's done. See you tomorrow in class.